Here we will discuss what is the output of the exception to the console and how we can decipher it so you can easily locate the source of your problem and remove it if possible. Do you remember that yellow text which was printed on the console when an exception was thrown and was not handled correctly? That's called a stack trace. Stack trace is a list of method calls that the application has made while an exception was thrown. At the start of our program, the stack memory is empty. When a call to a method is made, a new frame is added to the stack memory on top of the already created ones. When an exception is thrown, for each stack frame, information is printed on the console, like the FQN of the class, the method, and the line where the code went through. This forms a trace to follow, where the exception was thrown, and to track the origin. Those print statements from each stack are called a stack trace. Let's examine an example to visualize better what I'm talking about. We will create a hierarchy of classes to simulate some real program workflow, so we can better see what is the actual stack trace. We have a class car, which holds a reference of an object of type engine. The engine class on its behalf holds a reference of type fuel tank and has a field, liters per 100 kilometers, which is an int. Fuel tank is a simple class which has an int field named capacity, which is a random number from 1 to 100. In the main method of the stack trace demo class, we create object of type car and we call its method getRemainingKilometers, which should give us, based on the capacity of our tank and liters per hundreds of kilometers of our engine, a rough estimate of how many kilometers we can drive without hitting the gas station. Let's examine the workflow. The main method calls getRemainingKilometers on our car object. GetRemainingKilometers of the car object in its implementation calls calcRemainingKilometers of the engine class and multiply it by 100. To calculate its value, the engine class gets the capacity of its fuel tank, and it divides the value by liters per 100 of kilometers. So the stack trace would look like the following. And the output is as follows. Let's examine what does this mean. Arithmetic exception was thrown by somewhere in the code. This is the first line of our stack trace. Looking below, we can safely remove the first stack frame, as it is not listed in the stack trace, meaning that exception was not found there. But look at the second line of the stack trace. It seems that the first trace of exception is found on line 14 in the engine class. If you examine the code closely, you will notice that liters per 100 kilometers is never given any value, meaning that the default value for an int is given implicitly, which is 0. That's how we found our problem in the code. Below in the stack trace, you can see the other information provided. You will notice that all the information and lines matches where our code calls were made in the different classes. Let's quickly examine one more example, this time with chained exceptions. The example is almost the same, but this time in the engine class we are catching any runtime exception and rethrowing engine exception, which is a custom unchecked exception I've created for the demonstration purposes. Remember, the focus here is on the stack trace, not how good or bad the code should be written. So, in the case we have the following output once we execute the program. When there are chained exceptions on top, you can find the actual exception being thrown, and below, in the caused by section, you can find its origin. If there are more than one caused by sections, scroll down to the bottom of the stack trace to find the root cause. Being able to decipher the stack trace is very important to easily find the source of your problems and fix them with ease.
Learn with Whizlabs. Success certified.